Welcome to InnoBuzz Java video tutorial part 18. In this chapter, we are going to talk about some advanced concepts in Java language. We will speak about some important things what we need to know if we want to develop high-level applications in Java. These will be some reusable software components. Some of them we were already talking about in the previous chapters. We are going to see them from a different point of view this time. These are the abstractions and inheritance. We will also talk about, again, the polymorphism and the iterators, and we will see the auto-boxing as well. Let's see the overview of the chapter. Reusable software components. The abstraction, inheritance, polymorphism, iterators, and auto-boxing, as I've mentioned. Reusable software components. These are, in any programming language, mean piece of code designed to perform a specified task. And while we developing, we can use these components in our code, and we don't need to rewrite them because these already are made. The base of object-oriented paradigm is the hierarchy of the program units. These program units are usable for anyone. So the hierarchy of Java classes and interfaces are implemented for reusing. We just import packages or using jar files, and we can get a lot of reusable components. It seems to be the opposite of the encapsulation, but we can override these methods if it is necessary. In the Java language, there are also reusable components named Java Bean. They are classes in the Java language conforming to a particular convention. They are used to encapsulate many objects into one single. That's the bean, and it is passed around instead of multiple objects. The Java bean has to be implemented by implementing this serializable interface, and its constructor has 0 arguments, and it has to allow access to its fields using getters and setters. These are the conventions that we have to take into consideration when programming with beans. In the java.beans package, we can find some useful classes and interfaces for developing Java Beans architecture. The Java Beans are also can be found in EE as a modular construction of an enterprise application in the server side. So inside the enterprise edition of Java. Continuing the discussion of this chapter, we will see that the inheritance and the abstraction also give us a way to reuse the program codes. Abstraction. We have already met abstraction in this video tutorial a few times. We are going to see a new point of view this time. The abstraction is the process by which data and programs are defined with a representation similar in form to its meaning or task, while hiding away the implementation. In computer programming, we can apply to control to data. by control abstraction. Control abstraction defines the actions and involves the use of the subprograms. The data abstraction allows handling data bits in meaningful ways. When we use abstract classes in Java, we don't implement the task. We have seen that in the practice. We just use a similar form define the main method of the class. And later we can use this form and we can reuse the abstract classes, extending our subclasses, and we set the concrete task. The abstract methods are similar to them. We just define the formal parameter list and the implemented task will be programmed later, so we will implement it later. The uses of interfaces has a similar concept to build a hierarchy in the Java program, but a class can have more implemented interface, while can have only one direct superclass. So this is also we have talked about the multiple inheritance performed by the interfaces and the single inheritance performed by the classes. The inheritance is the other way to make reusable components, as we've talked about. In the Java language, classes can inherit attributes and behavior from pre-existing classes named base or superclasses. The resulting classes are the child, sub, or derived classes. Implementation inheritance is the mechanism whereby a subclass reuses code in a base class. The attributes are the fields of the class and the behavior is described by methods. Many object-oriented programming languages, just like Java, permit a class or object to replace the implementation of an aspect, typically a behavior that it has inherited. It is called the overriding. We should care with this because there are a lot of misunderstandings. We will clear it when speaking about the polymorphism. In Java, all classes inherit from the object class. It defines us some basic methods like clone, toString, hashcode. These should be overridden before we use them in our classes. The equals, or for example the wait and the notify, they are used with the threads. So these are all involved in the object class by default. Let's see the Java rules of the inheritance. The derived class inherits the public and the protected members, constructors, methods, and fields of the superclass. It doesn't inherit the private members. If the base class and the child are in the same package, the child inherits the package private members of the parent. Override. When you write a new instance of a method in the derived class that has the same signature, so the method name and the parameters and the returning type, as the one is the base class. Hiding. When we write a new static of a method in the derived class that has the same signature as the one in the base class, we can also hide fields with redeclaring them with the same or another type. But it is not possible to reduce the visibility of the members in the child classes. We can use the super word, the super keyword, to make access to the members of the base class from inside the derived one. You have seen it in the practice as well. Let's talk about the difference between the hiding and the overriding. The static type of an object is that type which defines when we name the variable. For example, my class object for my interface object. When we make a new instance by calling the constructor of the class, it will specify the dynamic type. When we can redefine or change the dynamic type with casting and referring to another object, the dynamic type can be static type, any subclass of the my class, or a class that implements my interface. The dynamic type is defined in runtime and it is changeable. We create a new object which has static type, my class, and dynamic type, my subclass, which is the subclass of the my class. And we create and we call an overridden method. We invoke method of the subclass. But if we call a hidden method, we invoke method of the base class. If both static and dynamic types are in my subclass, we just can call the methods of this class. This task is in some way related to the responsibility that we were talking about in previous chapters, that all classes responsible for themselves. So they will know what methods, what behaving they should do, and depending on how they are called, we are going to call the method of the subclass or the parent class, depending of if we call the hidden method, then we can call the parent class, for example. So this is something which is specialty of Java here. This kind of polymorphism. The definition of polymorphism refers to a principle in biology in which an organism or species can have many different forms or stages. In object-oriented programming languages like the Java program, polymorphism means that one object can define unique behavior with overwriting the superclass methods and can share some of these the same functionality of the parent class. That is what we have seen. We didn't name it when we were talking about it in the previous slide. We can call the method of the child class and we can read the method of the parent class from the same place in the program. The polymorphism has the advantage of objects that can change places, so they can be exchanged. The different classes can be used in the same places. So when we define a reference argument in our program, we can change it with another reference which is a child of that, or implements the defined argument. Because the child can do everything that the parent can in Java. It has the same methods and fields, and even more. Iterators. We have used the while and do while and for and enhance for loops for iterating. We know the syntax of them. But there's another thing, the iterators. We can use them when we have more objects collected. These items could be primitive types or objects too. For processing, we use an iterator object. The iterator is an interface. We have to implement it. It consists of 3 abstract methods. The hasNext, it returns true if the iterator contains more items. The next returns the next element in the iteration. It can throw no such element exception. The remove, it removes the collection's last element by the iterator. It can be called once per call to next. In the Java language, for iterating object, there is the call actions framework that we were already talking about in the previous chapters, that includes many classes, interfaces, and algorithms for representing and manipulating the collections. Auto-boxing. All primitive types in Java have the wrapper class that value what the variable represents as an object. The auto-boxing is the automatic conversion of the Java compiler that makes between the primitive types and their corresponding object wrapper classes. For example, we can declare a primitive type variable with initial value, like int e equals to 1. This means we create a new variable and call the constructor of the integer class. We need these classes when we want to make a collection of primitive type and objects. In these cases, we can process them together, for example, with an iterator that we have just learned. But there is sometimes not suggested to use these as an object, because primitive types can be a bit faster, but never slower, and the immutability, so that they can not be changed after creation of the wrapper types, make it the usage impossible. The wrapper classes are in the java.lang package. They implement the serializable and the comparable interfaces.